Hi everyone, welcome back to Lulumath. This video is on solving problems with linear equations, and these are general word problems. There are going to be some follow-up videos on solving word problems with linear equations, some on distance, rate, time problems, some are on money problems, some are on geometry problems, some are on consecutive integers. So make sure to check those videos out for specific types of word problems with linear equations. So you'll need to know how to solve multi-step equations. You will also need to know how to translate verbal expressions to mathematical expressions or equations. Both of those videos are available at lulumath.com as well as the Lulumath YouTube channel if you'd like a refresher before you watch this video. So let's get right into it. We have a word problem in front of us, and generally I'm not a big fan of giving like steps when we're solving things. I want to make sure you understand, but having a type of process to follow when we're looking at word problems helps us to organize the information and helps us to problem solve. So I'm going to model for you how I would problem solve a question like this. So the first thing I would do is I would identify all the key information. So as I read this, I'm going to highlight any key information that's going to help me out. Miguel, Deja, and Yuko each made a post on social media. Miguel got 25 less than twice as many likes as Yuko. So that's important information. And we also know that Deja got 3 times as many likes as Miguel. Altogether, they got 278 likes. So how many likes did each person get? So I've identified what it is that I know. This is going to be some information that's going to help me out. Now I'm going to identify what it is that I want to know. So I want to know how many likes each person got. So I'm going to say here I did step 1 in yellow, that's the key information, and then step 2, identifying what I want to know, is in green. After that, I would draw a picture to help me visualize what's going on in the problem, if drawing a picture will be helpful or if it's necessary. In a question like this, drawing a picture isn't necessarily going to help me, so I'm going to skip that step. And then this next part is written in bold because it's so important. We want to write specific let statements. Now, from my experience as a teacher, a lot of students will say, well, I don't really feel like writing let statements, or they don't help me out, and then they get stuck on how to start writing their equation. But all the students that are willing to write their let statements find that writing the equation is so much easier to set up. So when we write our specific let statements, I want you to ask yourself 2 questions. I want you to ask yourself, how many things do I not know? Because the number of things that you don't know is going to set us up for the number of let statements that we need to write. And just because a question might be asking for one specific thing, there might be multiple things in a problem that we don't know. And we have to write our let statements for all of those things to help us find even just that one thing that we might be looking for. I also want you to ask yourself, what is everything based on? And I'll explain to you what I mean as we write our let statements for this specific question or this specific word problem. So looking here, I don't know how many likes Miguel got. I don't know how many likes Yuko got, and I don't know how many likes Deja got. So in this specific problem, there are 3 things that I don't know, which means I'm going to need to write 3 let statements. And you know what? I'm going to put Miguel in blue, and I will have Yuko in red, and I will have Deja in orange. Since I'm going to have 3 specific let statements, I need to ask myself, what is everything based on? So I know what my first let statement is going to be. Writing that first let statement sets the stage for the rest of my problem solving that I'm going to do here. So I know Miguel got 25 less than twice as many as Yuko. So that means that Miguel is based on Yuko. So I need to know Yuko's amount first before I can find out Miguel's. And then we also know that Deja got 3 times as many likes as Miguel. So in order for me to figure out what Deja got, I have to know what Miguel got. But in order for me to know what Miguel got, I have to figure out what Yuko got. So that means that everybody is based on Yuko. So Yuko is going to be my first let statement. And it has to be specific. So I'm going to figure out how many likes Yuko got. So we're going to say let the number of Yuko's likes equal. And if I don't know how many likes Yuko got, I can call it whatever variable I would like. I will call it y. All right, now we're left with Miguel and we are left with Deja. But since Deja is based on Miguel, I need to write a let statement for Miguel first. So we're going to say let the number of Miguel's likes equal. Now, since we don't know how to solve equations with multiple variables in them, we know how to isolate variables, but we don't know how to solve an equation with multiple variables in it yet at this point in time. So we can't use a different variable. So if Miguel got 25 less than twice as many as Yuko, then I'm going to write down twice as many as Yuko. So twice means to multiply by 2, so we'll say 2y. And then we're going to say 25 less than that amount. So 2y minus 25. Now we have to be really careful because whenever it's 25 less than an amount or any number less than an amount, we need to have that amount first and then subtract 25. And if you want a refresher on that, then make sure you check out the video on translating verbal expressions. All right, so now we've figured out Miguel's let statement. Let's figure out Deja's let statement. So we're going to say let the number of Deja's likes. And it tells us here that Deja got 3 times as many likes as Miguel. Well, if Deja got 3 times as much as Miguel, and Miguel's is 2y minus 25, then I can take this 2y minus 25 and multiply it by 3. But it's 3 times the whole entire thing, so I'm going to say 3 multiplied by 2y minus 25 in brackets, because again, it's 3 times the entire expression 2y minus 25, and if I don't have brackets, then I'm only doing 3 times 2y as opposed to 3 times all of this 2y minus 25. Your let statements are the hardest part, so congratulations, you've gone through the hardest part. Now I want to write my equation. So I know that altogether they got 278 likes, and altogether that means I need to add that all up together. So that means that Yuko's likes plus Miguel's likes plus Deja's likes all together will equal 278. So I can just add up Yuko's amount, which is y, and then add to it Miguel's amount, which is 2y minus 25, and add to that Deja's likes, which is 3 times 2y minus 25. And all together, I know that that's going to equal this 278 that we got right here. Okay, well now that I've done that, I just can solve my equation. So I'm going to go through and solve my equation like I normally would any multi-step equation. So here, I can't do anything with a y, I can't do anything with a 2y minus 25, but I can distribute this 3 through. So 3 times 2y is 6y, and 3 times negative 25 is negative 75, and that's going to equal 278. Well, 1y plus 2y is 3y plus 6y is 9y, and then negative 25 minus 75 is negative 100. I'm going to get rid of this 100 by adding 100, and when I add 100 here, it gives me 0, and when I add 100 here, I get 378. Divide both sides by 9, and I end up getting 42. And I forgot to say that the next thing we want to do is solve our equation, so we're done with that step, which is awesome. But now we need to answer the question, and the question is asking us, how many likes did each person get? When we answer a question, we need to go back into our let statements. So since we know that y equals 42, we can use that information to figure out how many likes each person got. So looking here, we know that Yuko's likes is represented by y. So looking here, we know that Yuko's likes are represented by y, and we know that y is equal to 42. So we know that Yuko got 42 likes. For Miguel, we know it's represented by 2y minus 25, and we know that y is 42. So I can just do 2 multiplied by 42 minus 25. So I end up getting 84 minus 25, which is 59. Now for Deja, we know that Deja got 3 multiplied by this 2y minus 25, but we know that this 2y minus 25 is 59. So we know that Deja's likes is 3 multiplied by 59. And 3 times 59 is equal to 177. So we can now answer our question. So therefore, Yuko had 42 likes, Miguel had 59 likes, and Deja had 177 likes. And then lastly, we have to ask ourselves, does our answer make sense? Well, it does make sense to have 42 as a number of likes, 59 and 177. These are all numbers of likes that we can get. It wouldn't make sense if we got fractions or decimals as our answer because we can't get 2.7 likes, for example, right? It wouldn't make sense if we got negative answers because we wouldn't have negative likes. Also, we can do a quick check to make sure our answer is right. If Yuko got 42 likes, and if Miguel got 59 likes, and if Deja got 177 likes, we can add all of these values up together and it should add up to the total number that we are supposed to get. So if I add 42 and 59 together, I would get 101 and then add 177 to that and I would get 278, which is the number of likes that we know is the total amount altogether. So we know we did this correctly. And that's what you need to do for a question like this. Okay? All right, in our next example, I'm going to model the problem solving that I would go through to solve a question like this. So the first thing I would do is identify key information. So I'm going to do that as I read the problem. So we know that Carla's mother is 4 times older than she is right now. Okay, we also know that 6 years ago, Carla's mother was 10 times older than she was. And we want to figure out how old they are now. So I've identified my key information and I want to identify what I want to know, which is step number 2. So I want to know how old they are now. Now I can draw a picture if it's necessary, but I don't have to. In this example here, drawing a picture isn't going to help me understand things any better, okay? And then now I want to write some specific let statements. And again, just like we did before, we're going to ask ourselves, how many things do I not know? And what is everything based on? So here I know that Carla's mother is 4 times older than she is right now. So in order for me to be able to figure out Carla's mother's age, I need to know Carla's age. So that's what everything is based on. So for starters, we're going to say let Carla's age now. And if we don't know it, I'll just call it X. We're going to let Carla's current age equal X. Well, if Carla's current age is X, we can use that information to write out a let statement for Carla's mother's current age. And we know that she's 4 times older than Carla is right now. And if we don't know what Carla's age is, but we call it X, then we can say that her mother's current age is 4 times as much. So we can say it is 4X. Now, not only do I not know Carla's current age, I also don't know what her age was 6 years ago. And we're talking about 6 years ago here. So I can say, let Carla's age 6 years ago. And if it's 6 years ago, then we take her current age and we just subtract 6 from that because 6 years ago is just minus 6 from now. And let's also write a let statement for Carla's mother's age 6 years ago. And if her current age is 4X, then her age 6 years ago would be 4X minus 6. All right, so these are the 4 things that we don't know. So we're going to use that information to write our equation. Now, one last piece of information that we haven't used is the fact that Carla's mother was 10 times older than she was 6 years ago. So literally, we're going to translate what this is saying into an equation. So it says 6 years ago, Carla's mother. So I'm going to write that out. 6 years ago, Carla's mother. And then here it says was. And for some of us, was might just be like a simple word that doesn't really mean much, but it means a lot because was means equaled. Okay, so because we have the word was here, we're going to say equals. And she was 10 times older than Carla was at the time. So that means that we have to take Carla's age at the time, which is X minus 6. And because she was 10 times older, we have to multiply that by 10. And it's 10 multiplied by the entire thing. Now we can solve our equation. So I'm just going to copy down this 4x minus 6, and then I'm going to distribute the 10 through, equals 10x minus 60. I'm going to get rid of this 4x by subtracting it. So I have a negative 6 left over, and when I subtract 4x from 10x, I get 6x, and then I'm going to copy down the minus 60. Then I'm going to get rid of this minus 60 by adding it. So negative 6 plus 60 is 54, and I have 6x left over. Negative 60 plus 60 is 0, so that's going to go away, which is what I wanted to have happen. Now I need to divide by 6 to get rid of this 6 times x. So when I divide both sides by 6, 54 divided by 6 is 9. So 9 equals x. So I've solved my equation. Now I need to answer the question, and again, I'm going to go back into my let statements. And my question is asking me, how old are they now? So I want to know how old Carla is now, and I want to know how old her mother is now. Well, if x is 9, then we can say that Carla's current age is equal to 9. She's 9 years old. And we can say that Carla's mother's age is 4 times 9. So she is 36 years old. So I've answered the question. So let's go ahead and write our therefore statement. And of course, we always have to ask ourselves, does this make sense? So if we get Carla's 9 and her mother's 36, this seems pretty probable because these values are numbers that make sense for ages. The mother's older than the daughter. If we end up getting that the daughter's older than the mother, then maybe something isn't right here either. But also, I can go back into my let statements and figure out how old their ages were 6 years ago and see if that works out for us. By the way, quick note. If you notice, when we wrote our let statements, we had 4 let statements, but we only used 2 out of the 4 let statements in our equation. And that's okay. Sometimes that's going to happen. We might not necessarily use every single one of our let statements, but we need every single one of our let statements because in order for us to be able to even get these statements here that we used in our equation, we needed these ones here. Going back to see if her answer makes sense, if Carla is currently 9 years old, then 6 years ago she was 3 years old. And if Carla's mother is currently 36 years old, then 6 years ago she was 30 years old. And 3 times 10 equals 30, so she was 10 times older than her daughter was 6 years ago. So this answer does make sense. Okay, and that's it for this video. If you have any questions, let us know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be useful, please make sure to subscribe and please share with others. Thank you, and we'll catch you next time. Bye.